Hello guys, let's move on to part 2 of UPSC Engineering Service Exams previous year's questions. In part 1, we have discussed all the questions of the year 2019 and one question from the year 2018. Let's move forward to the second question of the year 2018. In the second question of the year 2018, we have this particular circuit and they're asking current across this particular element. Okay, so we are going to use nodal analysis, and I have solved exactly this same question in a detailed manner in one of my previous videos, and I will be linking that video in the description box, so make sure you check the description box as well. Now moving back to the question, we have this question and we have to find out current across this resistance. Okay, get yourself a reference node, then assign reference voltage to it, and then you move from reference node to your voltage source. If you face a positive terminal, then you write negative sign, and if you face a negative terminal, then you write the positive sign. Okay, so here what we are doing is V0 minus, okay, 2 volt upon the resistance you met in the way. Okay, so this will be V0 minus 2 volt upon 2. Okay, and same goes for this. See, here you happen to have a positive terminal, so you will be writing negative, so it will be V0 minus 3. Okay, V0 minus 3 upon the resistance that you have met in the path, so that will be 2 ohm over here. Same for this, and you write the value of current as is. Okay, the current source over here, so you write it as is, and on solving you get the reference node voltage value as 2.25. okay, and applying Ohm's law will give you the answer as 2.25 ampere. It is a pretty easy questions, nothing to be worried about. Then we have another question based on nodal analysis. Here you have to find out the current across this 5 ohm resistance. Okay, so the funda over here is this 5 ohm resistance is not drawing power alone. Okay, a combination of these two resistances is drawing power from the sources. So when you apply Ohm's law, you are not going to write V0 upon 5, but you are going to write V0 upon 8. Why? Because these two resistances when combined are drawing power from the sources. Hence the current which you will have here is the one that will be passing through this and this as well. So you need to write 5 plus 8, 5 plus 3, which is 8. Okay, so you get your answer as this. Now let's move on to the fourth question. We have this question which seems pretty tricky, pretty difficult, and you don't know what to do. The question here is triangular wave voltage applied across the terminals of a 0.5 farad pure capacitor at equals to 0. The corresponding current wave is, okay, the question says that if you apply a triangular wave voltage across a capacitor, then what would be the current wave of that same capacitor. So what we are doing here is first we are calculating dV by dt. This graph is provided as V by T graph. Okay, now we are calculating dV by dt. Okay, after calculating dV by dt, you put it in the formula for current across a capacitor. Okay, this is what we are doing here. First we calculated dV by dt, and then you put it in this formula and you get the value of current as this. Now you have to keep one thing in mind, which is that if you apply a triangular wave voltage across a capacitor, the nature of current waveform is rectangular. Okay, and it is starting from minus 5 ampere. Okay, we have solved it is minus 5 ampere, so this will be the right answer. And one thing I want to say is I have not completed the chapter of series parallel RC, RL and RLC circuits, so there will be some questions which you will have some difficulty in understanding, and I will make sure that I will post those chapters as soon as possible. So this is one among those chapters which will be this question will be all the more clear after I post notes regarding those chapters. Now we are moving on to the last question of this video, which is a theoretical question. Okay, VI relationship of series RC and voltage source circuit is given via these equations. Okay, which among the following is or are correct? Again, I have mentioned that I have not covered RC, RL and RLC circuits. So these types of question will be easy. Okay, the answer over here is 1 and 2. These two equations are correct. Okay, I will make sure that I post videos regarding those chapters as soon as possible. So this is all for part 2.